In my last video, I hacked Sekiro to make easy mode, where posture damage done by the player is increased. I had fun doing this, so I aimed my sights to From Software's bigger hit, Elden Ring. I was not really interested in making an easy mode, as Elden Ring already has many ways to make playing it easier, such as leveling, weapon upgrades and spirit summons. Instead, I wanted to try and make an alternative way to play Elden Ring, with no weapons. The bare fists do a laughable amount of damage in the normal game, so let's make them do more. If you want to try this at home, do note that you should disable the easy anti-cheat program that's normally active in Elden Ring, and play the game in offline mode. Because you wouldn't cheat in online games now, would you? Let's start by making a new save and character.
Please assume the position.
I already got curious and tried to make my character have more body hair than what's allowed in the character creation menu, but that did not yield any results. So our character will just be an average looking caveman, with distinctly blue eyes. Alright, it's been a while since I fought the grafted scion at the start, so let's give it a try. And no, I'll just jump off. Now that we are properly in the game, let's start making our mod. We start with finding some code that changes character health upon taking damage, much like in Sekiro. It's easier in Elden Ring as the game gives you the numerical values directly. Once we have found the player's health, we verify that it's correct by changing the value and freezing it. Then we find out what writes to the address to find code that modifies health. An annoying feature of Elden Ring is that it crashes very easily when you attach the cheat engine debugger into it. So make sure to quickly save the code addresses you find before it crashes. I find the character data structures of the player and an enemy and compare them for differences. It seems that the same memory region is all 0 for the player as it was in Sekiro, so I will use the same data to determine if the character is player or not. Then I take the Sekiro mod project and modify it to work with Elden Ring instead, changing code addresses and health address offset. I do a quick test to see if it works by multiplying damage towards non-player characters by 100. Oh. That was unintentional. I realized that I treated health as a 64-bit value when it's actually 32-bit, which unsurprisingly broke the damage logic and killed everything. Let's fix that. And yep, now I'm One Punch Man. Currently, as the damage multiplier is applied on health change, it does not apply if I don't do at least 1 damage when attacking. Now that I have the base logic set up, it's time to implement my idea. Instead of just increasing flat damage of the punch, I want to make the punch do more damage for each consecutive attack. So I will implement a counter into the mod to keep count of hits that the player has made, and multiply damage by the current counter. To make it a bit weird and probably overpowered, I turned the counter into a power function, so that a constant multiplier is to the power of the number of consecutive hits. Essentially, this causes the damage to increase in an exponential curve. First slowly, then insanely fast. At first, it didn't look to have an effect, but after increasing the multiplier, I was able to clearly see the punches start to do more damage, and after a while, the damage really starts to stack up. Next, it's time to implement cooldown. The counter goes up on every punch, which becomes overpowered after a certain point, so I made another thread in the injected DLL that reduces the count over time. So if you don't punch things frequently enough, you lose your damage. I increased the multiplier so that I can test the cooldown more easily. Now the damage clearly still increases, but if I take a break between punches, I notice that I do less damage. What I noticed during making this mod, which I didn't in the Sekiro mod, is that the code addresses can change when you restart the game. This does make sense when you think about it. The operating system decides what memory processes can use and can decide to allocate the program code to a different location. The address that is shown in Cheat Engine is a relative offset of the process's base address. Each time we start our mod and perform code injection, we need to find out what this base address is in order to find the correct memory location for the code. We do this with a bunch of Windows API calls, which also means that the logic needs to be separately written for other systems like Linux. Next, I wanted to show the current counter value. Since our punching caveman does not need FP, we'll use FP to display it. So we do the usual. We find the offset of the character's data structure where FP is found. Then we implement methods to change it in our mod. I then made the code change player's FP when the counter changed. But it didn't work. FP did not change. I first thought I might have had the wrong address, but when debugging it, I was able to change the player's FP. Something else was wrong here. When debugging further, I realized that the player pointer was not always pointing to the player. It was pointing to something else in the game. When inspecting this data that it was pointed to, it was some other character in the world that I did not know. I tried to set their health to 0 out of curiosity, but that did nothing. This was either a character that was not fully loaded, or is something that follows some special logic, like the chariots in Fingerfold Hero's Grave, maybe. Anyway, I had to compare this with the player to find another piece of data that properly differentiates the player character. And now, the FP changes work as intended. Let's get out of this cave and test our mod in the open world. And I seem to have killed both Vare and the Tree Sentinel during my coding accident. After killing through the Stormgate ruins, I can confirm that bare fists are now viable. While this does work, I wanted to improve it so that the calculated new damage is actually shown on the screen. This requires exploring the game's code a bit more, to find a function that calls the health code, which is executed when a character takes damage. The assumption is that the same function will also render the damage done onto the UI at a later point. Ghidra is an open source decompiler that can decompile assembly into pseudo C code. I use Ghidra to explore the game code and find a location that seems to contain both a pointer to the character taking damage and the amount of damage itself. The damage is stored in some kind of struct, so I can hook a function into this code and change the data in that structure, without having to return any values from the hooked function and play around with assembly any more than needed. And once that's done, the game crashes. But after correcting some pointer arithmetic, it works. Now, the scaled damage is also shown in the UI. And yes, as you can see, balancing the damage multiplier is quite important in order to keep the game challenging.
That's a lot of damage!
Another issue that I found earlier is that since we don't check that the character doing the damage is the player, any NPC that damages another NPC in the world will increase the punch counter. I first tried to fix this by finding a reference to the attacker in the damage event code, but after a long search I could not find any such reference. So I resorted to another method, checking if the player character is currently attacking or not. I found some value in the character data structure that seemed to change to certain numbers when the player's attack animation was running, so I decided to use those as the condition for increasing the counter. It does not work perfectly, but at least this prevents the counter from going up while the player is just running around. I then clean up my code a bit so I can inject another function into the game to a different address more easily. By debugging the player data address, I find a piece of code that reads the data on every frame update. I inject the function into this code so I can constantly have an updated pointer to the player character. Otherwise, the player would need to take damage before the mod activates, as there's no other way to find the player reference. And now, when I start the mod, it instantly finds the player reference. I injected a third piece of code in the hopes of showing the count in the text area that shows the name of the weapon skill. I managed to do it in the end, but the problem is, it doesn't update in real time. You would have to switch weapons in order to show the updated counts. So I kind of gave up and just stick with the FP instead. The final change that I did was to make the cooldown speed dynamic. Basically, the higher the punch count, the faster it decreases over time. As the punch damage gets exponentially more powerful, this is a good way to nerf the high punch counts, while making it easier to build up the count when it's lower. And that's it. I could further iterate this, but this has taken way too long already for one video. So finally, let's put it to the test by starting a new save with our beloved caveman Fisto, and go punch the hell out of Godric. Quickly after starting the new save, I noticed that the mod is not working properly. I tracked down the issue to be related to the attack checking code. It might be that the magic numbers can change, so they are not so reliable. I decided to just remove this logic at this point. Soldier of Godric proved to be quite easy. But Tree Sentinel provided a nice challenge. The damage multiplier and cooldown would probably need to be adjusted for a more experienced player, but luckily I am not that good. Next up, Margit. And then we kill a traitor on the way. And then we fail at parkour. And then we fight Godric. There we go, and that's it for this video. Fun mod which was also fun to make. Is it balanced? No, but it was fun. If you liked the video, leave a like and subscribe for more programming and tech related things.